Hello, we are here for one more lesson of this T-FLEX analysis training course, and today the topic will be the interpretation of a result. Reaching this point of the course, I do believe that it is important to show you how to interpret a result, because it is something that we've been doing in the previous lessons, and it is a procedure that we show also in all the videos where we show how to calculate different topics inside T-FLEX. So to show you this, I've opened one of the examples that the program has, which is this bracket model. We have a couple of characteristics that I will describe. So this is a model that completely defined as steel for the, the, the complete parts of the assembly. Then we have a couple of restraints. We have a restraint in this back face, a fixed one, and we have partial restraints in the places where we simulate the screw holes, and one more for contacting this face. Besides, we have a load in this horizontal face here of 2.5 thousand kilos. So this is what we have to execute the calculation. So the idea now it is to go to analysis. The mesh sheet is done also, and we run the calculation and wait a little for the results. In terms of this particular model, we want to interpret the result checking the safety factor, which is the main criteria for the structural strength of this part. And we will assume, or because it is something correct, that this safety factor should not be less than 1.5. Okay, so let us see now that the results are done. We will open the list results, and we have one of the factors. One of the results is this factor of safety by equivalent stress. So we have this, and I want to change this scale, and I want to see from a maximum of 3 to 1.5, and what I get now are the red areas, which are below this safety factor of 1.5, which should not happen. All the rest above I will ignore for the present study, because it should be areas where there are no problems. So if I have these structural problems, the idea is to change the design and rerun again the calculation, so that we can check if things change. And I will act in three main areas. The first one being this a very weak area by the result that is shown. I will increase the thickness. Then I will increase also this dimension here, and for these areas which have a very concentration area of problems, I will add a radius to this edge here, from in one side and also on the other side. We can do this in several ways. I have some variables already prepared. Going to parameters, variables. The first one is this D. The D is the thickness of the supports. So I will basically double this from 4 to 8. And I will change also this dimension here, which is 10, and I will change it to 12. Okay. And now I will regenerate my model. I can, sorry, and I forgot one of the important topics, which is to add some radius here. I will be generous and will create a radius 10. So and we'll do the same on this side and do okay, good. So I think everything it is changed now. I can try to check. It is not the best place to do it. Not sorry. Measure. I was doing this wrong. From this place to this place. To this place here. So 8. Okay, good. So it is updated. And we'll go again to analysis. We'll rerun the mesh creation because it's a little different now. Okay, close window. Good. With the same conditions, the mesh it is redone, and we'll run again the calculation, which should give me, we hope, a different result. So 3, 1.5, and let us see if it is different. Okay, completely different. So you see that we had an area with very big problems in this area. Now it is green, so safety factor around 2, which is good. We have also another area here due also to the small thickness of the support, so this is different, even that we still have some points a little more yellow, so but completely under the red area. And the other points were these ones, this edge that was created, that was dissipated now with the radius that we've added in the two sides. So I would say that a little point on top, we could change also a little more, but I would say that for the purpose, this kind of structural design change completely solves the issue of the results and the problems with the safety factor we had previously. So this is the kind of analysis that you can do, checking the results, and this is also the type of intervention that you can realize on the part to correct problems that you may check seeing the results. Any help with this topic? Let us know. Send us your questions, your examples, and we will give you all the necessary support.